Hi friends, today we'll discuss about introduction to operational amplifiers. So first, we'll learn something about amplifiers. The basic job of the amplifiers are to amplify the input signal. That is, it is converted weak signals into strong signals. Next, operational amplifiers. Operational amplifiers is like the general amplifier. It is also called as an op-amp. Operational amplifier is an integrated circuit. Integrated circuit means below we see that the diagram of integrated circuit. See that. Next, operational amplifier is used to perform various linear, nonlinear, and mathematical operations. Operational amplifier is used such various operations, mathematical operations that are subtraction, addition, differentiation, integration, like that. Okay. Next, an op-amp is a direct coupled high gain amplifier. Op-amp is high gain amplifier. Next, you can operate op-amp both with AC and DC signals. We can operate op-amp with AC and DC signals that are alternating current and that too direct current. Next, operational amplifiers are one of the basic building blocks of analog electronic circuits. Operational amplifiers, we use basic building blocks of analog electronic circuits. Next, here we see that the diagram how the IC working. See this. Next, circuit diagram. Here we see that circuit diagram of operational amplifier. An operational amplifier is a basically three terminal device, that is V minus, V plus and V out. It consists of two high impedance inputs, that V minus and V plus, and one output terminal, that is V out. Next, the terminals are named based on the phase relationship between their respective inputs and outputs. Next, one of the input is called the inverting input, marked with negative signs. Here V minus is the inverting input, that is marked with negative sign, and V plus is the non-inverting input, that is marked with positive sign. Next, the third terminal represent output, V out. Next, inverting and non-inverting input. First, inverting input. The basic job of inverting input is inverted the data which we have given to that. That is, if we give positive input to it, it will be inverted that the output goes to more negative. If we gave negative input to that, it will be goes to more positive. That is the job of the inverting input. Next, non-inverting input. In non-inverting input does not invert any data. That is, if we give positive, it would be goes to more positive. If we gave negative, it would be goes to more negative. That's it. Here the integrated circuit of operational amplifier and circuit diagram and pin. Here we see the circuit connecting integrated circuit. That is, here integrated circuit have 8 pins: 1 2 3 4 5 6 7 8. Pin number 1 is connected to the ground. Pin 2 and 3 was input terminals. 4 is power supply, and 5 is does not work. 6 was the output, and 7 is power supply. 8 is the ground. That's it. Next, basic block diagram of op-amp. An op-amp can be conventionally divided into 4 main blocks. That blocks are: 1. Input stage or input differential amplifier. 2. Gain stage. Next, the level transistor. Next, an output stage. Here note, we see It can be used to perform various mathematical operations such as addition, subtraction, integration, differentiation, log, etc. Op-amp used to perform these type of operations that are addition, subtraction, integration, differentiation, log, etc. Here we see the basic block diagram of op-amp. Here V1 and V2 are the inputs. It would be goes to input stage. Next gain stage, level shifter. Next output stage. Finally VO is the output voltage. Operational amplifier. The important characteristics or parameters of an operational amplifier are as follows. Operational amplifier has four characteristics that are open loop voltage gain, output offset voltage, common mode rejection ratio, and slew rate. First we'll see open loop voltage gain. The open loop voltage gain of an op-amp is its differential gain without any feedback path. Open loop voltage gain of op-amp is differential gain of it. Differential gain. Mathematically, the open loop voltage gain of an op-amp is represented as AV. AV equals to VO by V1 and V2. VO is the output voltage and V1 and V2 are the input voltages. Next, output offset voltage. The voltage present at the output of an op-amp when its differential input voltage is 0 is called output offset voltage. That is, when the differential input voltage is 0, then the output voltage of an op-amp is called output offset voltage. Next, common mode rejection ratio. Common mode rejection ratio of an op-amp is defined as the ratio of closed loop differential gain AD and the common mode gain AC. Mathematically, common mode rejection ratio can be represented as it is equals to ratio of closed loop differential gain and common mode gain, that is AD and AC. Here note that the common mode gain AC of an op-amp is the ratio of the common mode output of voltage and the common mode again common mode gain is the ratio of common mode output voltage and common mode input voltage. Next, slew rate. Slew rate of an op-amp is defined as the maximum rate of change of output voltage due to a step input voltage. Here, slew rate of an op-amp it is the maximum rate of change of output voltage, that is dVo by dt. Mathematically, slew rate can be represented as it is maximum of dVo by dt. That's it. Here VO is the output voltage. Slew rate is measured in either volt per microsecond or volt per meter second. So now we'll go through types of operational amplifiers. Generally, operational amplifiers are two types, that are ideal op-amp and practical op-amp. First we'll see ideal op-amp. Here an ideal op-amp exists only in theory and does not exist practically. We use ideal op-amp in theory only. It does not exist practically. The equivalent circuit of an ideal op-amp is shown in the figure given below. Here we'll see the figure of ideal op-amp. Here now we will see the characteristics of an ideal op-amp. Here input impedance is denoted by Zi. Here Z is the impedance and I will be the input. Now input impedance is defined as the ratio of input voltage to the input current. In ideal op-amp it will be infinity. Next, output impedance. Here Z is the impedance and O will be the output. Output impedance is generally defined as the ratio of output voltage to the output current measured. That's it. Output impedance in ideal op-amp will be 0 ohms. Next, open loop voltage gain. Open loop voltage gain is denoted as AV. Open loop voltage gain is defined as the difference between input voltage to the output voltage. In ideal op-amp, open loop voltage gain will be infinity. Next, if the input voltage Vi equals to 0 volts, then the output voltage will be 0 volts. Why? Because in differential amplifier, due to virtual short concept, the output voltage will be same as that of input voltage. If we gave 0 volts to the input, the output voltage also be 0 volts. That's next. Bandwidth is infinity. It means an ideal op amp will amplify the signals of any frequency without any attenuation. It means an operational amplifier will amplify the signals of any frequency from 0 to infinity. It will be amplified any frequency. Next, common mode rejection ratio. In ideal op amp, common mode rejection ratio is infinity. Slew rate. In ideal op amp, slew rate is also infinity. It means the ideal op amp will produce a change in the output instantly in response to input step voltage. Next, practical op amp. Practically, op amps are not ideal and deviate from their ideal characteristics because of some imperfections during manufacturing. Practically, op amps are not ideal. It will be deviate from their ideal characteristics. It does not depend on their ideal characteristics. It has, because it has some imperfections. It is not perfect. Next, the equivalent circuit of practical op amp is shown in the following figure. Here we'll see the figure of practical op amp. Characteristics of practical op amp. In practical op amp, input impedance is in the order of mega ohms and output impedance it is in the order of few ohms. Open loop voltage gain will be high. Next, when you choose a practical op amp, you should check whether it satisfies the following condition. When we choose a practical op amp, we see that these conditions are satisfied. First, input impedance should be high, output impedance should be low, open loop voltage gain should be high, output offset voltage should be low, operating bandwidth should be high, common mode rejection ratio should be high, slew rate should be high. That's it. Next, application of op amp. If there exists a linear relationship between its input and output, a circuit is said to be linear, and a circuit is said to be nonlinear if there exists a nonlinear relationship between its input and output. Next, op amps can be used in both linear and nonlinear applications. Use op amps in both linear and nonlinear applications. Next, the following are the basic applications of op amp. Basic applications of op amp is inverting amplifier, non-inverting amplifier, and voltage follower. Inverting amplifier. An inverting amplifier takes the input through its inverting terminal through a resistor R1 and produces its amplified version as the output. Here we'll see the figure. Here R1 is the resistor. The inverting amplifier takes the input through these resistor, and amplified it. This amplifier not only amplifies the input but also inverts it. This amplifies amplified it and it also inverts it. It will be inverted the input data. Here, the circuit diagram of inverting amplifier is shown in the following figure. We'll see the figure. In the circuit, the non-inverting input terminal is connected to the ground. Here, the positive terminal is called as non-inverting input terminal. It is connected to the ground. That means we have to apply 0 volts to the non-inverting input terminal. According to virtual short concept, the voltage at the inverting input terminal of an op amp will be 0 volts. Due to virtual short concept, the voltage at the input inverting input terminal is also be a 0 volts as that of non-inverting input terminal. Next, the nodal equation at this terminal node is shown below. Let in diagram we'll see resistors as R1 and RF, and voltages is at Vi and Vivo. Vi is the input voltage, Vivo is the output voltage. Let us consider R1 is Rin, resistor input. Next, let us consider Vi as Vin. According to Ohm's law, V equals to IR. Here, from that, I equals to V in minus V out by R in and RF. Here, voltage is input voltage and output voltage. Resistance is as that of input resistance and feedback resistance. Therefore, we have another input terminal as V2. So, we separate it. I equals to V in minus V2 by R in mine equals to V2 minus V out by RF. We'll separate it. I equals to V in by R in minus V2 by R in equals to V2 by RF minus V out by RF. Now, this is like A equals to B equals to C. So, now let us consider V in by R in equals to we take this term as a left hand side. Now V2 as common, 1 by Rn plus 1 by Rf minus V out by Rf, and as I equals to we'll take V2 as 0 volts. From the above equation we have to put V2 as 0. Now I equals to V in minus 0 by R in, that equals to 0 minus V out by RF, that equals to RF by, we'll cross product it, RF by R in equals to 0 minus V out by V in minus 0. The closed loop gain is given by V out by V in equals to minus RF by R in. Here note that the gain of the inverting amplifier is having a negative sign. It indicates then that there exists a 180 degrees phase difference between the input and the output. Here the negative